In the area of science and gigantic mysteries, conversations about what existed before the Big Bang have fascinated scholars and thinkers for quite some time. This enormous question doesn't just test how we could decipher the universe, it challenges the actual boundaries of human knowledge. Imagine standing at the edge of existence, looking into the colossal unknown, pondering what lay there before our universe was conceived. The Big Bang, which established the beginning of time, space, and all that we know, raises an unsettling question. Was there something a second earlier? Previously, could there have been a condition of nothingness, a calm before the cosmic gathering began? Or perhaps, was there something much more alarming that existed before time itself? As we dive further into this question, science takes us on a journey beyond the universe's beginning point, into ideas that challenge our consciousness. Physicist Brian Cox, well known for his exploration of the wonders of the universe, suggests that something surprising might have existed before the enormous detonation. He pushes us to reconsider our understanding of reality and existence. In this discussion, we will dissect theories, research, and the fascinating mysteries that might reveal what happened before everything else. We will explore concepts like self-replicating expansion, quantum fluctuations, dark energy, and even multiverse. The answers we uncover might astonish you, but they could also open new understandings of our place in the universe. Get ready to journey deep into a world beyond imagination and science, where the unknown still lurks in the shadows, leaving scientists both amazed and unsettled. We must explore what existed before the Big Bang and why these theories challenge everything we thought we knew. To appreciate what may have existed before the Big Bang, we first need to analyze what the Big Bang truly was. Scientists define the Big Bang as the moment when the universe became extremely hot and dense, expanding rapidly to trigger the formation of all matter and energy. When we look at the night sky, we see evidence of this fiery beginning, with galaxies spreading outward from a single point. But why did this happen? Furthermore, was there a period before this dense, hot start? According to the theory of cosmic inflation, there was indeed a before, and it was not empty or peaceful. Vast expansion suggests that before the Big Bang, the universe was in a cold, empty, and loose state, essentially like an immense vacuum. However, this vacuum wasn't entirely empty. It contained an enormous amount of energy that fueled rapid expansion. This inflation of space itself happened so quickly that it laid the groundwork for everything that followed. In a fraction of a second, space expanded at unimaginable rates before slowing down, allowing energy to transform into matter particles and the fundamental forces we associate with the Big Bang. But what was the nature of this energy? Why did it suddenly cause the universe to expand? And why did it stop? Experts believe that cosmic inflation may have created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly, with tiny pockets forming here and there, each pocket representing a universe, including our own. This idea, known as the inflationary multiverse, suggests that there could be countless Big Bangs, an infinite number of universes. The universe we live in may be just one of many. This vast, mind-bending reality challenges our comprehension of the very nature of existence and leaves us wondering, what else is out there? The idea of nothingness before the Big Bang is speculative but not real, according to our current understanding. Even if you strip the universe of energy, particles, and radiation, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other elements that weave an intricate cosmic tapestry. Even if we imagine removing all of these forces, leaving behind a void, the universe would still generate new kinds of energy. This reality alone baffles scientists, as it suggests that true emptiness might be impossible. Space itself has properties, rules, and constants that prevent it from being completely void. Imagine trying to create a region of absolute nothingness, no particles, no radiation, and no energy. Even then, quantum fields and fundamental constants would still exist. This suggests that even nothingness has properties. One phenomenon that supports this idea is zero-point energy, which represents the lowest possible energy state of quantum fields. Even in this state, particles can momentarily appear and disappear, creating a ghostly fluctuation of activity in what should be empty space. This challenges our idea of true emptiness and suggests that something existed even before the Big Bang, something that scientists are only beginning to understand. One of the most astounding theories in modern cosmology is the concept of eternal inflation. If inflation caused our universe to exist, it's possible that it has been occurring forever. Brian Cox speaks of an astonishingly vast inflationary multiverse, a realm where universes are continuously created and expanding. Imagine each Big Bang as a spark, igniting another universe, while inflation continues in other regions, generating countless new universes. This process could, theoretically, continue indefinitely. This idea of an infinite chain of universes gives birth to a fascinating concept, a fractal universe, where each new universe might create its own Big Bang. Every universe exists as an independent domain, unaffected by the others, due to the rapid expansion of space. For researchers, this hypothesis is both exciting and unsettling, as it suggests a never-ending multiverse with no definitive beginning or end. Imagine our universe as just one tiny piece of a colossal cosmic structure, forever expanding, constantly creating new universes. What if the mind-boggling truth is that there is no before or after, only a timeless pattern of universes forming and dissolving? Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe is not just an assembly of matter floating in space but a vast network of energy fields that permeate the cosmos. These fields are like invisible oceans, with particles acting as waves or disturbances. Even at their lowest energy state, known as the vacuum state, these fields remain active. Particles can momentarily appear and vanish, borrowing energy before returning it. This phenomenon results in virtual particles, entities that exist for a fraction of a second before disappearing, leaving behind only a faint trace of their presence. This discovery challenges the idea of a true void. Even in an empty universe, where all matter, radiation, and energy are removed, quantum fields would still be present. They would continue fluctuating, preventing absolute emptiness. This revelation leads to an intriguing question. If quantum fields create particles, and particles create matter, could the universe itself have emerged from this nothingness filled with energy fields? Dark energy, a mysterious force that currently drives the accelerated expansion of our universe, might hold further clues. Some theories propose that dark energy existed before the Big Bang, acting as a remnant of a primordial energy field. If dark energy existed in a much stronger state before our universe began, cyclic cosmology challenges the very nature of time itself. If the universe undergoes endless cycles of expansion and collapse, then time may not be linear but rather an infinite loop, repeating endlessly. This concept suggests that what we perceive as the beginning of our universe was merely the latest rebirth in an eternal sequence of cosmic events. One of the most compelling versions of this theory is the Big Bounce hypothesis. According to this idea, the universe did not originate from an absolute beginning but rather emerged from the remnants of a previous cosmos that contracted before expanding again. This cycle of contraction and expansion could have been occurring for eternity, with each universe giving birth to the next in an endless chain of existence. But if this is true, what happened before our current universe's expansion? Was there a previous universe that collapsed into a singularity, leading to the birth of our cosmos? Some physicists propose that quantum mechanics may prevent a complete collapse, instead triggering a rebound, a bounce, that initiates a new expansion phase. If this is the case, the Big Bang may not have been a singular moment of creation but rather a transition point in a vast, repeating cosmic cycle. The role of quantum gravity in pre-Big Bang theories. One of the biggest challenges in understanding what happened before the Big Bang is the lack of a complete theory of quantum gravity. Currently, general relativity describes gravity on large cosmic scales, while quantum mechanics governs the behavior of particles on the smallest scales. However, these two theories do not fully align when applied to the earliest moments of the universe. Physicists believe that a yet undiscovered theory of quantum gravity could bridge this gap and explain what existed before the Big Bang. Some proposals, such as loop quantum cosmology, suggest that space and time may be made up of tiny, discrete units, preventing a true singularity from ever forming. Instead of an absolute beginning, the universe may have gone through a quantum phase where time and space behaved in ways we cannot yet comprehend. This opens up possibilities such as a previous universe that collapsed and then rebounded, leading to our Big Bang. A timeless quantum state where energy fluctuations gave rise to our universe. A multiverse scenario where infinite universes emerge from quantum foam. Parallel universes and the multiverse hypothesis. One of the most mind-expanding theories is the idea that our universe is just one of many, part of a vast multiverse where countless other universes exist, each with different physical laws, constants, and properties. There are several types of multiverse theories. 1. The inflationary multiverse, the idea that cosmic inflation generated numerous bubble universes, each undergoing its own Big Bang. 2. The quantum multiverse, based on quantum mechanics, where every possible outcome of a quantum event creates a new parallel universe. 3. The brane multiverse, a concept from string theory suggesting that our universe is a three-dimensional brane floating in a higher dimensional space, with other universes coexisting alongside us. 4. The cyclic multiverse, the idea that multiple universes go through cycles of birth and death, constantly regenerating in an eternal process. If the multiverse is real, then the question what existed before the Big Bang may not even make sense. Our universe could simply be one of an infinite number, each emerging from an ongoing process of cosmic creation. Final thoughts: the limits of human understanding. The question of what came before the Big Bang pushes the boundaries of human knowledge. Our current theories, whether inflation, cyclic cosmology, quantum gravity, or the multiverse, are still incomplete. Science continues to refine our understanding, but some aspects of the universe's origins may remain forever beyond our grasp. However, each new discovery brings us closer to answering this grand mystery. Whether the universe had a definite beginning or has always existed in some form, one thing is certain: our search for understanding is far from over. As physicists and cosmologists continue to explore the deepest secrets of the cosmos, we may one day uncover the truth about what existed before time itself. Until then, the mystery remains, fueling our curiosity and driving the next generation of scientific breakthroughs. It could mean that what existed before the Big Bang was just another version of the universe, one that collapsed only to give birth to our current universe. For researchers, this theory offers a rich response to the question of origins, proposing that there is no true beginning. Since its inception, the universe has existed in some form, transcending our ideas of time and existence. Early-stage gravitational waves are another intriguing idea that could hold clues to what existed prior to the Big Bang. Gravitational waves are ripples in space-time caused by massive cosmic events, and scientists believe that if early-stage waves were ever detected, they could reveal insights into the universe's earliest moments. These waves could serve as echoes of what came before the Big Bang. Should they be identified, they might provide proof of the universe's previous states. The potential discovery of early-stage gravitational waves would be a groundbreaking breakthrough in our comprehension of the universe and the concept of eternal universes forming and collapsing. Waves disrupting the very fabric of time and mysterious forces creating and pushing the boundaries of what exists challenge not just our present understanding of the universe but also force us to confront our deepest existential questions. As we dive deeper into the mysteries of what existed before the Big Bang, we must investigate additional speculative theories that could offer glimpses into a universe beyond our own. One such idea is the concept of the no-boundary condition, proposed by physicist Stephen Hawking and others. This theory suggests that the universe doesn't have a traditional beginning in the sense we understand. There is no singular point of origin. Instead, the universe could be like the surface of a sphere, with no edges or boundaries. According to this theory, the universe's beginning is nothing more than an illusion, shaped by the flow of time, which may curve back on itself in such a way that the concept of a start point becomes redundant. Consider that the Big Bang was not the source of the universe but rather the transition point of an ongoing process. If this theory is correct, then asking what happened before the Big Bang becomes a meaningless question, as there was no time before that event. Another theory that necessitates a radical shift in our approach to the question of what existed before the Big Bang is the idea of quantum foam. At the smallest scale, the universe is governed by quantum mechanics, and one of the most mind-boggling implications of this is that empty space is not truly empty. Even in a vacuum, quantum fluctuations occur, causing particles to spontaneously pop in and out of existence. These fluctuations may form a sort of foam at the very smallest scales, where spacetime itself is subject to turbulence and unpredictable changes. This quantum foam could have been the precursor to the more familiar structure of the universe that we observe today. In this view, the Big Bang could have been the moment when the quantum foam transformed into the smooth spacetime we experience, effectively bringing our universe into existence from a state of extreme quantum uncertainty. This concept has significant ramifications for our understanding of time, space, and causality. Some scientists have proposed a more philosophical framework for comprehending the universe's origins, the idea of a cosmic egg or a pre-universe that existed in a collapsed state. This speculative model imagines a time when the universe was a single, infinitely dense point, known as a singularity, before the Big Bang. It is possible that this singularity contained all the mass, energy, and information that would eventually give rise to our entire cosmos. Over time, some suggest that this cosmic egg might have undergone a kind of cosmic breathing process, expanding and contracting in cycles. The birth of our universe could have been the result of one such expansion, and when it eventually reaches its end, it could collapse back into a singularity once more. This cycle of birth and death might have continued for eternity, and our current universe might just be the latest iteration of this cosmic cycle. Such a model challenges traditional concepts of linear time and posits that time itself could be cyclical, with no absolute beginning or end. On a more speculative note, some theories explore the possibility of a multiverse, a collection of parallel universes that each operate under their own set of physical laws. In the context of the multiverse, the Big Bang of our universe might have been just one event among countless others, each giving rise to a different universe. The multiverse theory posits that there could be infinite universes, each with its own unique history, laws of physics, and even different versions of reality. Some scientists believe that the existence of a multiverse could explain certain features of our universe, such as its fine-tuning for life. If there are countless other universes with different properties, it should come as no surprise that one of them has the ability to support life as we know it. The holographic principle is another fascinating theory that suggests the nature of our universe might not be what we think it is. According to this principle, all the information that makes up the universe could be encoded on a two-dimensional surface, like a hologram. This concept, which has its roots in black hole physics, suggests that our perception of a universe with three dimensions might be an illusion, a projection of data encoded on a distant surface. If this idea is correct, then the entire universe, and potentially even what came before it, could be seen as an intricate pattern of information. The holographic principle suggests that, much like a hologram, our universe might have originated from a much simpler, lower-dimensional structure, potentially explaining how something as complex as the cosmos could arise from seemingly empty space. Finally, we must also consider the role of string theory, which suggests that the primary building blocks of the universe are not particles but rather tiny vibrating strings. These strings could give rise to everything we experience, from matter to forces, and they exist in higher dimensions beyond the familiar three-dimensional space. Some versions of string theory even suggest the existence of extra dimensions of space that we are unable to perceive directly. In this framework, the Big Bang might have been the result of interactions among these higher dimensional strings, leading to the creation of our universe. If string theory is correct, the universe may have been born from a higher dimensional space that is beyond our current understanding, adding yet another layer to the question of what came before the Big Bang. These theories, ranging from the quantum to the philosophical, all present radically different perspectives on the origins of the universe. While we may not yet have the tools to fully answer the question of what existed before the Big Bang, each new theory brings us a step closer to understanding the nature of our reality and the universe's ultimate origin. Whether through the lens of quantum mechanics, cosmology, or string theory, the search for answers continues to push the boundaries of human knowledge. The role of dark matter and dark energy. Another significant consideration in understanding what may have existed before the Big Bang is the role of dark matter and dark energy, two mysterious components that make up the vast majority of the cosmos. Dark matter, which does not emit or absorb light, is believed to form the scaffolding on which galaxies are built. Dark energy, on the other hand, is an even greater enigma, responsible for the accelerated expansion of the universe. Some scientists propose that before the Big Bang, the universe might have been dominated by a different balance of dark energy and dark matter, creating a pre-Big Bang cosmos with properties vastly different from what we observe today. If dark energy behaves differently under extreme conditions, it could mean that prior to the Big Bang, a universe-like state existed in equilibrium before eventually transitioning into the explosive event that created our universe. Understanding dark energy and its effects on cosmic evolution could provide key insights into whether the universe will continue expanding forever, slow down, or collapse in a future big crunch, potentially leading to yet another rebirth of the cosmos. The cyclic universe hypothesis. One of the most fascinating theories suggesting a pre-existing cosmos is the cyclic universe hypothesis. This model posits that the universe undergoes endless cycles of expansion, cooling, and contraction, eventually leading to another Big Bang-like event. In this view, the universe did not emerge from nothing. Rather, it has always existed in one form or another, continuously evolving through cycles of death and rebirth. This idea is closely related to brane cosmology, a theory from string theory that suggests our universe is just one of many three-dimensional brands floating within a higher dimensional space. When two such brands collide, it could trigger what we perceive as a Big Bang, initiating a new cycle of cosmic evolution. The cyclic model challenges the traditional notion of a singular beginning and instead suggests that the universe's past is as infinite as its future. If this theory is true, then asking what existed before the Big Bang may be the wrong question altogether. There was always something, just in a different form. Primordial quantum fields and vacuum energy. Another possible precursor to the universe involves primordial quantum fields and vacuum energy. In quantum mechanics, even what we consider to be empty space is filled with fluctuating energy. Some physicists propose that before the Big Bang, a vast quantum field existed, containing potential energy in a dormant state. At some point, a fluctuation or instability within this field could have triggered an event akin to the Big Bang, transforming latent energy into the particles and forces that make up our universe. If true, then our universe was born out of a quantum event rather than an absolute beginning from nothing. This concept aligns with the inflationary theory, which suggests that a brief but extremely rapid expansion of the universe occurred moments after the Big Bang. If inflation can happen once, it may have happened countless times before, possibly in different regions of a larger cosmic landscape, reinforcing the idea of a multiverse where Big Bang-like events are happening constantly across an infinite expanse. Could we ever know for certain? Despite these fascinating theories, proving what existed before the Big Bang remains one of the greatest challenges in physics and cosmology. The very nature of time and space breaks down at the singularity of the Big Bang, making direct observations impossible. However, advancements in technology, gravitational wave research, and deeper explorations into the nature of dark energy, quantum mechanics, and extra dimensions may one day provide indirect evidence of a pre-Big Bang universe. If we can detect echoes of previous cosmic cycles in the cosmic microwave background, CMB, radiation, or uncover traces of past universes hidden within the structure of spacetime itself, we may finally get a glimpse of what came before our own cosmic beginning. For now, the question of what existed before the Big Bang remains an open mystery, one that continues to challenge our understanding of reality itself.